Hello everyone and welcome to today's session. But before introducing our guest speaker, I would like to inform you that lecture will almost go straight away for around 2 hours, and later on there will be a Q&A session. There you can use the raise hand option and directly ask the questions. I will allow you to ask the questions directly from our guest speaker. And also during the lecture, if you have any questions to ask, please put it in the chat box. Then at the Q&A session, I will forward those questions to Mr. Samita, our guest speaker. Okay, then I would like to introduce our today's guest speaker. Actually, he has gained his bachelor's from University of Moratuwa with the first class honors degree in 1994. Then he has done his master's in Saitama University with the Fulbright scholarships, and also he earned his Master of Business Administration from University of Colombo, and he's a chartered engineer. And as a chartered engineer, he has more than around 22 years post-chartered experience. And when it comes to his memberships and affiliations, he's a corporate member in IESL, and also he is a corporate and executive committee member in Society of Structural Engineers Sri Lanka, and also he works in alumni of Harvard Business School, and also he's a member of Japanese Concrete Institute as well as Japan Society of Civil Engineers. And also his current employment, he is the current director of Architectural and Building Consultancy Directorate, which we call RDC Private Limited, and also he is a visiting lecturer for University of Moratuwa as well as University of Colombo. And also I would like to mention some of the projects he involved with as the director of RDC: Norris Canal Improvement Project, Health System Enhancement Project in 250 district hospitals, then NEI Cambodia, then Faculty of Technology in Sabaragamuwa, Kegalle, Rajarata University projects, and also in UGA Hills, Victoria, and UGA Kegalle projects. When it comes to his professional experience, he has gained experience in project management and participate in project meetings, progress monitoring, then controlling, reporting, and document control, and also construction management of high-rise buildings, human resource management, and coordination of subcontractors. And further to that, project management, documentations, and record keeping, and also contracts and claims. And I spoke about his professional experience. Further to that, I would like to mention that he's an all-rounder. In university, when he's in university, he is the most outstanding inter-university player of the year in 1993, and he captained the university rugby team, and he did rugby, football, swimming, and rowing in university. So I'm not holding much, sir. I would like to invite you to discuss a timely topic: strategies for project management and good practices for construction. Please welcome Engineer Samita Upendra Jayakodi. The floor is yours, sir. Thank you.
Thank you, Samit. Thank you, Tarak, also giving this opportunity. So I have changed. Better that you'll mute you mics. Otherwise, we will be listening to some unwanted communication. And going on the strategies of the project management aspects and also good practices, I would rather prefer that it will be taught or lectured under high-rise building, which is my major area. But as far as other projects are concerned, all these heavy engineering projects are concerned, same scenarios, practices is being, you can utilize. because under high rise, I can give a lot of practical examples I personally get involved in. And to add a bit to the introduction, it is unfair that I have not mentioned about my former employer, that is ICC, where I worked for 25 years. So lot of experience and exposure I have taken during my 25 years tenure at ICC. So I'm very grateful to that firm. And now I am in consultancy, chapter, and it is RDC now. So going on to the content. So content is little hectic. We'll try to do as much as possible under the topic, but time is also limited, and my area current will power will be cut off somewhere around 9 o'clock. So we'll manage our time effectively by going little faster. Then under the content, I'll be giving introduction, then major areas that under project management that we have to look into, then softwares in project management, what is the involvement, then the tendering aspects lead to project management, then pre-bid or pre-tender planning, then the bidding plan, or rather we can mention it as tendering, planning and organizing. After that, post-bidding, that is post-tender, that is the execution phase. So under that, I'll be talking about substructure, superstructural, then project monitoring concerns. Then if time permits, we'll discuss about commissioning phase concerns last, and also dispute resolution in a nutshell. So introduction to project management. So project management, so what is a project is most important. Project is a unique and temporary endeavor, and also which create a unique product. So temporary and unique is the most key words here. And ultimately we will be giving a product, service, or some sort of a result. So that is a project, temporary and is unique. Then what is management? Management is generic definition is effective utilization of human, financial, physical resources to achieve organizational objectives, right? And by performing the key management areas, that is planning, organizing, leading, and controlling. So thus I will concern about the management functions, generic management functions, as planning, organizing, leading, and controlling. So under any management practice, we have to have all these four in a very balanced way. So for example, if you don't plan, you can't manage. That is the basic one. If you have a plan and you don't organize, lead, and control, that is also no management. You may have a very good organizing and leading and everything, but you don't have controls, there is no management. So under project, which is temporary and unique, we have to function these four generic management functions well. So under project management, we will be talking about what are the planning tools and how you organize it to bid. And to lead, we must know the technology. Then we must practice the leadership qualities, then teamwork, then controlling aspects. So what is project management? In a big way. The project management is no exception as management, but it has very special features, right? So those are limited period and between specialized teams, very situational. Then it subjected to varying resource levels, HR, funding also varying, spectrum is varying, because when you're starting, we'll do what you call concrete structural works, excavation, form work, reinforcement, concreting. But later on, we will be doing MEP works, testing, electrical, blah, blah. So in the early stages of a project, we may require a lot of bar benders, carpenters, and so on. And later, we will be requiring very less people like the primer. But we will be requiring electricians, tilers, painters, scaffolding, erecting, riggers, likewise. So resource level also varying. That is also very special feature. And situations are different from project to project. Even the next, DOE project will be having different situational criteria. So likewise, uncertainties are many, external constraints are many. Then it is subjected to high level of interdependencies, and also demand all leadership styles, right? And situational leadership, maybe people-oriented leadership, work-oriented leadership. So even a leader has to change his leadership attitudes and styles in different stages. So because of that, it is very special. So if you take a bank or regional bank office, that management is very monotonous, and it is there's a system, there's a status quo. But here, though there's a status quo, we have to have a lot of changes. That is why project management differs from the general management aspects. Then in the construction project life cycle, we have different areas. One is project initiation. Under that, you do the project planning. So project management plan, we have to have creation. Then organizing, we have what we organize: human, finance, material, machinery, all the thing. Then project execution, which are the deliverables. Then monitoring, project, boundaries. Then we will have the, management of time, speed, quality, cost. In addition to that, we have to go with compliance with standards. Then we have to safeguard the environment as well as health and safety. So those are the things that we have to plan, organize, direct, and control. Then after that, we have to do the closing up, that we have to disperse, that is releasing our resources, starting up a new one, and closing up the balance. Then we do commissioning and, hand over and, go away. So that is the normal life cycle of a project. So from the initiation until closes, we have to manage all these 4 generic aspects. Then some myths of project management. We believe in some myths that project manager is the key. So normally we say he is the man. So it is teamwork. Then projects are directing jobs. We say shouting and go in the front and that stuff. Generally projects are not directing, but major component is planning. There should be a good plan. Then progress is the key. Sometimes we think the speed is the key. Yes, but going above on the timeline is very important. But it has to be balanced with quality, cost, and safety. We can't negotiate because of the speed, the quality, the cost, the safety, and also environment. Then project management, we normally think it is a science and art, 50-50, but it is not so. So it is 20-80, like, learned stuff is 20, 80 is artistic, or the experience. So it is based on tacit knowledge rather than the learned knowledge. That is why when project manager becoming matured, then he become more efficient and well experienced and more effective on a project. Then major resource is sometimes we call a material machine, but it is human resource, talent, and the people is very important. Then productivity is the key, but actual one is retention of skills is key. Then training given adopting the state-of-the-art technologies is key. Methodology selection is key, not the productivity. Productivity is automatically get generated if you retain the skills, talents, and apply the correct way of doing it. Right people, right time, right material is very key. Quantity surveying sometimes is a supporting service we consider. No, it is a major strategy force. Sometimes their advices are neglected by the project managers, but it should be customary that we seek daily quantity surveying advices and controls to manage projects. So quantity surveying is a billing machinery. Sometimes we think it is a core management unit which is making profits and safeguarding profits. Then there are no teams. It is one team, and we have to amalgamate. Sometimes we complain about in the project management there are bad rates and good rates. So, and if there's a bad rate, it is a quantity surveyors or the bidder's responsibility. It is not. So there could be bad rates as well as better rates. So we have to balance. Then claims and QS responsibilities are, it is a QS responsibility, but it is everybody's responsibility, but maybe led by a quantity survey. So construction, quantity surveying, everything is interdependent activities in a project. So we should know these things before we go into the thing of the project management education. Then major project areas to be managed is very, very important. And I have given all the planning documents and the tools on these major areas. So why I have scooped up this area is because some project managers unfortunately manage one or two aspects of what I'm telling. He may be a scope manager, but you call them as project managers. Then he might interest in progress and time management, but it is not like that, but it is a big picture. So we have to manage scope, progress and time, quality, safety, environment and health, cost, communication and data and reporting, human resource and subcontracting, procurement, contract management, resources and waste management, then protection and security, risk management, and we have to do integration management as well as averting, not safety, but it is a risk management. So from today, we have to seek the big picture. Sometimes we may be seeking only 1, 2, 3, 4, And sometimes we are neglecting communication and data and keeping the data and reporting management, because keeping the data is very important for the next project, because each and every project is a capital, investment. So it's experience, it's losses, it's profits, and technologies all should be carried forward. That is why it is very important that reporting management also. Sometimes we left all these things. So if you are going to do a better project management aspect or exercise, we have to have a balance in all the aspects. Integration is mixing everything. It is like cooking. And so under scope, there are tools, BOQ specification drawing. So I have given here. Then progress monitoring, we have the CMS, that is construction master schedule. Then S-curve, look ahead programs, minutes, KPIs, whatever. Then compliance management, we have a quality manual, IESL documents will be there, and rework scheduling, analysis, likewise. Then safety, we have safety manual, OSHA manual, ISO, registry, environment manual. We have to have all these tools. So that gives the plan. Then we have to, according to the plan, we have to organize. So this ISO is supporting very much in this regard, because it formulates a lot of documentation prior to a project. So, and it's customized and standardized to a particular organization. So ISO is a common document. So from there, we can extract all these procedures, planning tools from that. Then cost management, we have monthly cost sheets, prime cost schedule, material schedules, labor, then reconciliation sheets, cost norms. Those are available. If not, from today we have to make it happen. In communication, there's a communication protocol for each organization or project. Then we have IT policies, then reporting, data security backups. That is very important. Then human resource subcontracting, we have schedule of subcontractor rates, then contracts and blah, blah. Then procurement is very, very important area. Timely procurement, just in time or early. Then procurement tracking schedule we have. Then contract management, to do so, we have the contract, then variation, extra work schedules, claim procedures, then correspondence has to be, in line with the thing. Resource management, we have reconciliation reports, resource histograms, blah, blah, blah. Then protection and security, then we have handing over schedules, inventory, security. So many planning documents will be there in the project. So if you are managing a project well, we have to have reference to all the documents. You can't avoid any. Then integration also happening under communication protocol, meeting schedules, then strategic organization plan, yearly plan, then annual organization master plan, risk management plan, then CRIS, that is key risk indicators, aspect and impact thing, which is coming under ISO and OSHA. So these are planning tools. Then in addition to this, we have other side documents, job diary, then progress, the test, records, quality, CMS, technical ISO document, monthly, blah, blah, blah. So these are some of the documents. So these are the planning tools. Then if you take the project team, there are 4 tiers. client and the principal or the promoter, then consultants are there, or the engineer to the project. Then contractor is there. Then other teams. Other teams are construction management teams, financing teams, other special subcontractors, special consultants like acoustic, green. Then local authorities, BOI, if you're doing duty-free, projects. Then material supplies will be there, the government, organization, authorities, then environmental authority, UDA, all things are other people. So there's a big team work. Then when we are amalgamating different teams or factors or entities, institutions, we have to have a good bond. So that is why each and every bond is being contracted. So the contract is a legal document under two parties or tri-party or maybe more that is abiding to fulfill some duty or activity. So when the teams are more, different contracts will be there. So the main contract will be there, subcontract agreements will be there, supply agreements will be there, 1000 agreements. So we have to, managing the procurement is also very key. Sometimes we miss one or two, three, the major key areas, which will, indirectly affect the effectiveness of our project management aspect. So we have to have balance, not to miss anything. Sometimes we do everything, but our safety and also quality management is bad. So then there will be a lot of repercussions. So the contract is the legal document that is coming in between. So in a project, even small project, there will be 200, 300 contracts. So there should be a contract. So all project managers should know what at least a contract and what are the contract types. And we have to incorporate a particular. Normally we get the quantity surveying help to formulate these contracts. Then type of construction contracts between parties, and also we can get the main contract. So these are some of the main contract that we will be getting. Lump sum contracts are there, fixed price. Then sometimes unique price contract will be there. Unit price. There's a unit, there's a price. More the units, then you pay. Then cost plus contract, cost plus fixed fee, cost plus percentage increment, cost plus incentive fee, and also cost plus guaranteed maximum, like thing. So when the unit price, cost plus, all are coming when the project is poorly defined. When the project is well defined, we can go for lump sum because less clarification or everything is clear. Then we can give a good quote. When there are risks, there will be a lot of safety factors. Then design build contracts will be there. Construction management contracts will be there. BOT and BOO contracts will be there. That is lack of funding. So we will ask the developer to fund. Then PPP, that is public-private partnership. That is also lack fund, where the contractor will formulate the design and build to investment opportunities will be capitalized by the contractor or the developer. That is coming under PPP, and a lot of buildings. Then roads, larger government oriented state sector buildings are coming, or projects coming under PPP. Then the project management softwares are tools. I have seen a lot of people are very slaves to these tools. And it is not a fashion. Tools we use to create a good environment, which is, to make our life easy. Because progressing, planning, we can't keep everything by heart. So that is why we are using softwares. But softwares is not project management. Project management, it is a supporting tool. So we must get the support from the tool and execute physically in projects. Many people are slaves to things, even design, even planning. You do all the thing under software, but you have not visited site. You don't know what is happening in the site. That's bad. So this is we have to when you're using a software, we have to scale it, visualize, then logical intervention has to be there. All has to be happen by human. So if the human who is using this tool is lack of experience, there will be repercussions in the output. So garbage in, garbage out, or lack of information is the input, then your reports also are not complete. And top features, we are using softwares for the different thing. I have given billing and everything, planning, collaborating, reporting, everything we can. So why not use softwares? So softwares we have to use aggressively, but intervention is human. So human touch is much appreciated and demanded. Then features of this thing, so you can keep all the data, safeguard, reproduce. So I have given computer and it is features and advantages. So in projects, we will be very extensively using MS projects in planning. So sometimes once the plan done, nobody looks at it. It's a huge 500,000 pages, 500 to 1,000 pages, but you don't utilize. But based on your requirement, you can make it summarize. Then for the planner who is planning this one, have not elaborate or transfer all this information to the respective doers. That is, there's a lacking. So this planning tool has to be simple and understood by each and every management tiers, and it has to be practical. So you can make very serious planning with floats and combination, blah blah blah, but ultimately you will be missing the execution. So what is important is the critical path, where we identify critical activities. Then floating also we have to identify. So where we can early start and the latest finish. So that between that you can move your activity. But in the critical activities, the float will be very less, because we will be putting critical and also milestones where we have to complete and jump into the next. Then we will be using MS projects, Primavera. There are different countries adopt other names. Sporo, the EC Can4, MS Excel is also there. I'm also using MS projects, then Primavera, and also Excel one, ERPs. And it produce, and it has to be, when you go beyond, it will lead to BIM, right? So BIM platform, all the teams will get amalgamated, and it is a portal. Then all the updated drawings will be uploaded there, all the minutes will be there, and there are limited access for different people can use different level of information, and the top people can enter all the tiers, and you can get. But in Sri Lanka, maybe very few projects are coming on the BIM. But if you have worked in Maldives, at least Singapore, Malaysia, you will come across the BIM platform. Then what is most important is not the data, but the information. So data is something like this, all these figures, but when you convert into information, it will give some trend lines, colors, then it is like a dashboard. So we can get some sensible information. So not the data, what matters, information. So sometimes our computer will be full of data, but nothing coming out as profit or loss or rate or rate analysis, something like that. So it no mean. Then when you move to pre-tendering, so when the projects are being offered, so whether you are in the client side or in the contractor side, we have to go for pre-tendering stage. So in there, we have to, if you take contractor, for example, we have to formulate the tendering team or the bidding team or the tendering and quantity surveying outfit, we call. And there are roles in the bidding. So there should be team leader who is inspiring, it's a leader, wisdom, innovative and team spirited and listener. Then we have to have a good coordinator in this tendering team, because now we are going to get a job or give a job. So when we are formulating this team, we have to find out this cast different people for this to act on these different roles. Then coordinator, organizer will, he will have knowledge in all the aspects. Then contract specialist should be there. He should be a good reader and a narrator. Then qualified in knowledge in contracts. Then civil expert should be there, who is know all the civil engineering aspects, construction. Then MEP expert, material expert, plant and equipment expert. Then there should be subcontract and labor specialist who is having good knowledge on outside rates, their outputs, then the market, demand and market rate, rates, and the availability in the all these aspects. Then material price expert, who is a good negotiator and a expert in material pricing. All the material he has at his fingertip, the prices and different location. Then there should be Mr. Calculus, who is very good at calculating without missing any major data. Then there should be a planning engineer who knows about planning and milestoning, productivity. Then scope extractor, who is getting all the basic material and the locations from the BOQ, have big picture about the scope. Informant, that is getting information from outside. So different companies now have these projects, and they have enough project or there are lack of projects. Their appetite for project, right? And are they going for better margin or lower margin to get a project? So that's informant. Then timekeeper, who is communicate the time. Okay, another 1 week we have to now wind up. Then intuition expert, the moderator, proofreader, compiler, then specialist, and extraordinary task seek, who is looking at very special things in this project. What are the basics, you will be have to consider. Then strategist, then won loss project post mortem expert, because past history, are we having the winning streak or losing, why we lost. Transport expert, claim, value engineer expert, and different people will look into their aspects, whether are there any value engineering that we can do here. That expert will look at it. And the environmental and social specialist, so they will know what is the environment and the green and blah blah. So this is the winning team. So how many casts? I have mentioned 24, but I have not come across this bidding team of this large people or large team. But many people can double or triple act on different aspects. So at least there should be more than 10 people who, if we are seeking a job, has to be formulated, abide to study the project and give a good winning quote for that. Then pre-bid phase concern. So we have to collect all the documents during a tender. These are very important project management, because getting the project in good way is the most important. That is the key objective, the default. Once we get the project, we have to get it in a very studied way. Then when you take the documents, normally we have to have 3 copies and give into different teams simultaneously. They can work on it. Otherwise, they have to wait until one. So, for example, BOQ. So nowadays we have soft copies. We can give each the BOQ to work on. Otherwise, people has to wait until one person complete the thing and hand over the BOQ. So likewise, distribution of available document between strategic teams are very important. So specification, then structural, then reports, geotechnical report, preconditions, then initial meeting minutes, then negotiation minutes, client nominated subcontractor, the brands, that's idea. All these things are the bidding pre-bid phase concerns. Then we have to do a very good initial site investigation. Take photographs, the roads, boundaries, blah blah, and seek our scope, whether the scope will go extra, and is there any variation opportunities it might come. Then we will strategize our bidding operation. Then check the survey plans, then the footprint of the building, and seek opportunity for claims and proposals or value engineering. Then extract main quantities and distribute to all from the BOQ is very important. Development of tentative program. Normally we develop about 5-page plan. There don't elaborate larger plan. I will show very rough plan to everybody to understand in a very quick way, but it should be carrying the rationality of construction. Then initial site investigation, as I mentioned, we have to seek many aspects: access to project, services availability, and to be hired and blah blah. Then topography, then the general geology, rock, soil condition, then historical value, human settlement, trees, water courses, then erosion probabilities, sloping ground, disputes, neighboring properties. So those are topographical and geological information we have to take. Then labor and material pertaining to that particular area has to be studied. The lodging, maybe catering, the food, For example, if you are working in, are we planning a project in Jaffna, we have to seek all the things. So topography, geology, different. Then labor material different, because we have to take from labor from here to there. Nowadays, daily salary would be 7,500 for a southerner, right? Who will go to work in Jaffna, maybe 10,000 per day. So imagine the labor rate. So if you come to down south, it would be 3,000, 4,000, something. But labor rate will be higher. For example, these are then security, vandalism, then the arrangement. If the project is larger, then there can be some pilferage and theft. Security is very important. Then locally available facilities, also very important, like soil pits, then mills, yards, dump yards, then quarries, and so on and so forth, because we have to buy material. So that is initial site plan. Then engineering study of the project, visualization is very important. You will intend the client, who is the client, consultant, then type of the project, funding agent, and other stakeholders, competitors, and this likewise we have to visualize. Then I mentioned that we have to extract the total material quantity. This is in pre-bid. Still, we have not taken the project to manage. So during this exercise, we will be taking all the levels. In the levels, what are the flow area, concrete, how many meter cubes, reinforcement, how many metric tons, formwork, brickwork, tiling, painting, and others, sealing, everything. So in a particular example, you can see that reinforcement total is 2,500 metric tons. This is without this BOQ quantity. So we have to add on the wastage factor and so on. And different, what are the bar diameters. Then formwork also, we can see that 150,000 formwork, the whole system. So extraction is very important. From here, we will go to the next. How many plywood, how many people, and so on and so forth. So that is major material quantity. Then we will have the big picture. Then in the bidding phase, about to bid, we have to develop, as I mentioned, the program, 5-page or 3-page main items, resource requirement, then main quantities, value engineering opportunities, or pre-qualify them as a proposal. If there's a value engineer proposal proposed by the contractor, we will take the benefit and divide into 60-40. We will keep 60, then client will have this. If the client proposes a value engineering, which is a reduction, but without negotiating the quality, the saving, we will it will be divided into contractor 20-80, some like some sort of a portfolio. Then extraordinary element in the BOQ specs. What are the things? Then input, market rates, pricing strategy, and some idea about the big picture. Then pre-qualification list, that is very important in bidding stage. Then timely submission. So in the bidding phase, we have to concern. So I said we have to do a basic program, something like this, 1, 2, and 3. That's all. So that will be given, or maybe a 2-year project, and everybody understands how the structure goes on and how the finishes goes on. So basically, they can have some idea when to start, when to finish, and there is no links, right? Then in this pre-bidding, the bidding phase, we will be taking from the earlier schedule monthly productive requirement. It is very important. Quantities in monthly requirement. So for this example, I can say that form work monthly production output requires 2,500. Reinforcement 80 metric tons. Brickwork 900 square meters. Likewise, month-wise, we will get all the monthly production requirement. So in the early months, we have only reinforcement, concrete, brickwork, excavation, those stuff. Later on, we will be having tiling, blah blah, painting, and so on. Per day, per month. So from the month quantity, we can derive daily productivity requirement. That is, in this project, daily we have to produce in the early first 3 months, 1, 2, 3. Each month we have to give 100 square meters per day. Reinforcement 3 metric tons per day. So from there we will jump into our labor requirement per day using norms. We have norms. For example, if you take foam work, if you are putting plywood foam work, normally the output rate is per day, not more than that. But if you are using a proprietary formwork system, you can go up to 5, 6, even 7 square meters per day per person. Then reinforcement, normally it's about 150 to 200 kilos per person per day. So based on that, we can calculate what is the labor requirement. So in this case, we require carpenters, 25 carpenters per day. So based on that, we can get all the labor requirement in months. So this is a more than 1 or 2 year project, and you can see that March, February, January, February, March, we have to have this labor force 97. Likewise, from the 4th month, we have to increase the labor strength 200. Likewise, we can calculate our labor force throughout the project. So there is a 400, nearly 400 workers in the 16th and the 17th, 18th month. So that is the peak. So we have to arrange our labor camps based on this. Sometimes we will be, based on this, we will be arranging labor camp for 200 people. Later on, once the building done, the balance we can send into ground floor, basement. Or else we have to have labor camp for 400 people. Gradually it can be increased. And preliminary, under preliminary, we will be charging it. So likewise, we can plan. So this is pre-tender, during the tendering phase. Then scaffolding requirement, also we have to plan in this pre-qualification or the pre-tendering stage, because we are now planning to get a project. So what are our involvement? Based on this, our cost will differ. Then we have plant list. There also we calculate our plants and in what and which quantities. So in this case, you can see that cross-cut. So that is for carpenters in early months, it is 10. And it is going up to 20. So 20 peak per day cross-cut saws will be required. So then we can cost it, maybe hiring or maybe buying. So quantity surveying that is why I told it is going hand in hand. Then material, requirement list. So based on the total, extraction, we can is required in this project. Sand, admixtures, metal, different bars, reinforcement, then hinges, then granite requirement, lock requirement, plywood requirement, brick requirement, block, tiles, ceiling, likewise. So when you have this one, we can negotiate with our suppliers. So sometimes we call forward integration. I will show that cement, if you have the bulk cement requirement in metric tons, it is 17,000. So it's a huge quantity. So we can negotiate with some suppliers. Okay, if I give all the aspects to you, what is your best price? And we can have a strategic partnership, that is we call forward integration, and we can get a better price than the market, assuring that we will give all the total material. We will buy from you, so your best price. So likewise, we can have a pricing strategy. So if you do a shaggy work, you will be missing this tool advantage. So if you go by this procedure, it is easy and it is very scientific. Then when you are pricing, there should be a formulating of pricing strategy. So normally bidding price is based on our pricing criteria. So it is amalgamation of basic cost, which is very common to each category. For example, basic cost in Colombo for grade 25 concrete for in major contractors, CS2s, Maga, ICC, Sanken, Access, like thing, the basic price is same. Then we to the basic price in total we add markups. Markups are addition or percentage increment. So if markup consists of profits, normally it is 5 to 10%. Then head office overhead, the overhead, site overheads, then different costs and risk factors, the quantity, price risk. Normally we put 3 to 5% in the quantity risk if we don't know the quantity. If you have very dicey in the pricing, we also keep a pricing percentage. So add on it is about 25 to 35% markups. And plus preliminaries. Preliminaries normally it is 5%, 8% from the total budgeted thing. That is how we check. Then after that you can have contingencies and the provisional sums. Sometimes it is fixed. So the bidding price will be decided based on your, very significantly based on your basic cost and the markup. So how you change? There's a general assumption that the basic cost is same, but it is different because basic cost also based on quantity. So if you take good quantity evaluation by looking at extracting from the drawing as well as the BOQ comparing, then you will understand what are the overestimation and the underestimation and what are the missing items. Then we can formulate some strategy for claims, variations. Then rates also very uncertain. Rate includes material wastage, labor plus plant. So if you the rate also generally basic price, rate also basic, but rate also can be manipulated if you use better material. That I told you that forward integration, then we can have the best price in the market for cement, formwork, even concrete. Then material wastage can be reduced by proper good control of quality, first time right, no rectification, good formwork. Methodologies are very state of the art. So material wastage, normally we put 5-6%, we can reduce up to 3%. So there's a saving. And the labor also, when you go for proprietary formwork system, hire and dismantle, and use appropriate plants and technologies for that, you can reduce the rate even. So you can actually basic cost also you can change. Then markup also can be reduced, because if you avoid the pricing risk as well as quantity risk. Pricing risk, we can have pre-agreements, early buy, and also in the rate we can pre-qualify. Okay, the dollar rate we assume is this, we will absorb 5% increment, but beyond that client has to jack up or something like that, pre-qualify. Likewise, we can give a value engineering. So the pricing strategy is very important to do pricing. Have a big picture, total, billionaire or millions in the project, and what are the percentage of each category it represents. So in this building, 25% is structure, finishes 34, MEP is 30-35%. So likewise, you can, based on the extraction in the BOQ, you can have this big picture. Then pre-qualify, condition. We are using this cement type, this cement reinforcement brand, formwork this, then aluminum brand and silicon is this, mixed design are this, early removal of formwork facilities are this. Likewise, you can pre-qualify. That is very important during this thing. Give elaborative assumptions. This is our dollar price, assume. Then tile brand is this. Likewise, you qualify. Then the pumping, pumps, then the AC, air conditioning, brands, we elaborate. Ironmonger, we elaborate. Then after that, client and anybody can't, govern asking the sun and the moon, because you pre-qualify. We price based on this categories. If there's something, then during the evaluation, they might come out. The guarantees and warranties, then nominated subcontractor, concerns, then electrical fitting and accessories, the brands and everything, missing items, risk, we can qualify. Then we have to check outcomes, right? You can use unit price rate to check whether your total figure is correct. Then output rates are there, steel concrete ratios are there to check. So if it is normal concrete, it is about 115 kilograms per meter cube in concrete. If it is a earthquake design, it is moderate, 150 kilos should be there. If it is moderate earthquake, not minor, well detailed, it might rise up to or risen up to 225 kilos per meter cube, little larger. So we can check if it is the structure is given as earthquake resisting and the reinforcement is very low, then we can pre-qualify. We think that it is missing the earthquake, moderation. Something like we can pre-qualify. Then if there's a claim or something, we have already pre-qualified. There are some mics unmuted, please mute it. Then analyze the bed gang, scaffolding, all the thing. So these are still we are in pre-qualifying, and we can do a bidding strategy. Low profit margin for structure, then MEP a little higher, then value engineering option we can propose. Then precise, extraction of quantities, clear scope, underestimate, overestimates we can say, and normally overestimation we do not qualify. Underestimation we qualify. This is the total will be more than this. Then qualify anticipated rates. For example, there is no rock breaking, no concrete breaking. if some structures appear during excavation. So we can qualify. If there's a rock breaking, chemical blasting, we will be charging 30,000 or 40,000 per meter cube. So that it's very important. So we can give a better rate there, but it is not coming into the evaluation because it is missing in the BOQ, but you pre-qualify. Then better client cash flow support proposal we can give. Then client also will be happy. Sometimes contractors tends to load the preload or the front end loading. So the client will see that they are try to capitalize on cash flow. Then they will be selecting some better contractor who is not capitalizing on the cash flow. Likewise, bidding strategy we can adopt, and we do the bidding and we have to win. So if our strategy and our working is very scientific and everything, you will be going on to scientific solution. And if you do it correct, do it right, then we can win a project because we also strategize the bidding quantities and the rates. Then once we win the project, then it comes to the execution. So the execution part, we have different areas we have to execute. Preliminary work, piling, then structural, the finishing, procurement, right, and wastage, testing, all the things comes in. So once we win a project, then send our team to construct. First instance is in the project management that we transfer all information during the tender period to the site. That is, we call office to site. So all the information, I have seen a lot of information missed or getting missed during this scenario. So each and every, we have to have a briefing from bidding team to the construction team. That is missing in Sri Lanka. Because of that, lot of vital information will be missed by the construction people, and later on they will find these areas we planned badly because lack of information. But the bidding team should have all these things, pre-bid meeting, negotiation criteria, and so on and so forth. For example, our concrete rate would be very low because in the negotiation, we may have given a very marginal rate for concreting. So if the information and the construction team has to have a lot of concern over concrete because wastage has to be very minimal, then they will take a lot of precautions to be very extra cautious on that particular area. Likewise, steel also we can do. So wastage has to be minimized then. So that is, this is how we transfer, have big meetings, special discussions. Transfer of knowledge from office to site is important. In initial planning, we have to, when you're going into the site, we have to have our organization chart. Who is the project manager, who is the coordinator from head office, and also the other stakeholders. Then who is our team, what are the areas, and as I mentioned in the project management aspects, who will handle. So there should be some officers, professionals handling that one. So in the organization chart, there are levels: responsibility, personnel. Those are the top people. They are accountable, not even responsible, they are accountable. And in the middle, you have functional consideration. So they will look after the divisional objectives. Then the lower people, they concern about trade concern, their activity. If there's a reinforcement people, they will look after that only. So you should never mix. But functional people, that is the managers, they should mix with the formwork to reinforcement, concrete to formwork, likewise. But if everybody is taking, even the top managers are also trade the concrete only, that is the problem. So in different levels, our objectives will be different. So don't think at project manager level that you are a trade considered person. That is, you are promoting only concreting only. No, you have to promote the functional harmony of the divisions and also the overall client management, blah, blah, everything. So there are, once the job is awarded, we have to prepare the detailed CMS. That is very detailed normally. For example, if you take Havelock City like project, there will be about 500 pages of program. And we have to have summarized, systems and also monthly program based on the major schedule. And there will be links, then milestones, and also what we call the critical path. Then we have to formulate based on our program as well as the cost, monthly output of cost, our S curves. So the S curve is for cumulative work done. We can now separate S curve for letter of credit, that is importation, line. Sometimes the client will directly pay that one. Then we have local, cash in bills, or we are going to bill it. Then cumulative LC value plus the cumulative cash in based on the interim payments get together will formulate this green line, which is the cash flow of the project. The red line is the cumulative work done. So you can see there's a strategy. So work done, there's a cost line also going on, cumulative cash out, which is the cost for the material. Then always there's a positive cash flow. So the contractor will have positive cash flow because work done and the cost, then the cash. So for example, if you take one work done, there will be a cost and there's a gap. So the work done and cumulative material procurement S curve also we can jot down. Then only we can take the actual, positive cash in. So always there should be positive cash flow. So in the instant or the initial stage, we will be getting the advance payment, maybe 15-20%. Then we have to maintain that one, buying and on the right time, right material. And based on that, it is cash flow management. It is being handled by S curves. Then we have to have major procurement units under different categories. For example, structure, we have to procure steel, plywood, cement, sand, metal, like thing. So likewise, aluminium, the fire, the plumbing, we have major procurement units. Then I told that the communication management, we will be using a communication protocol. So this is a particular communication protocol. Who will initiate and to whom it will be go, and to whom it will be copied, and to whom it will not being copied. So the major areas are, you get client, then the consultant and the contractor and the other teams. Under areas, you can have technical, then the details, the reporting, then the commercial, the environmental health and safety, then consultation and site management oriented stuff, then bill oriented stuff, quantity surveying, blah, blah. So these are the things that, and communication protocol is there. Then under preliminaries, we have to do the site acquisition, bond, building the office, stores, car parks, labor camp, fencing, material yards, stocks, washing bays, machine plants, garages, staff quarters, stormwater, septic tank, getting furniture, then ceremonies of opening, bar bending yard, maintenance yards, power supply, signage, garbage, disposal, all the things are preliminary. So there's a preliminary charge also. So normally it is 5 to 8%. Some projects 10%. So the planning site is based on site activity, efficiency, then general movements, control of and security, accommodation. So there we have to come out with a mobilization plan. So in that all these facilities will be placed in a plan in the project. Without this, don't start. So these are basics of project management. Preliminary plan, and executing that plan is most important. Organize the material, lead them, execute and control. Check whether these things are happening. For example, this project, you get the building site, office, machine plant, then material stacks, vehicle washing bays. When each vehicle leaving the site will be washed and sent. And then security gates, labor camps, toilets, stores, everything's there. Then we have to open up the religious ceremonies, rituals, something like this we perform in the initial stage. Then the other ceremonies are sword cutting, the opening ceremony, all the things we have to organize in the initial stage. Then we move on to the leveling and setting out, surveying, initial excavation, and preparing the ground. So this is one example in Colombo site. Fencing, a large fence, 6 meter high. Then open up the initial excavation. We found that some very old foundations. So extra work. So demolition by assuming this, we have put a breaking rate for concrete. So we can claim. Once pre-qualified. So we'll give a very good, better rate. So from the very beginning, we will be profit making on the project. Then site clearing, then acquisition, then putting up your office, machine plant, general, access roads, right? Labor camp, then sanitary facilities, improving bathing facilities, then and that is also can be maintained, and the bathing for everybody. These are temporary stuff to attract people. So when you give basic requirements to people, there will be a lot of people. Won't be any issue to retain. Then what do you see underneath this bobbin yard, the cutting beds, bending tables, and the reinforcement stacks. So these are also preliminary work. And machine plant, large one, tower crane erection, and so on. Then leveling. So when you're leveling and setting out, we have to have the plans, the site plan and the contour maps. Then study that one based on the given details. So first we have to take spot levels, check the boundaries like this. So this is particular example of a project. For example, the side boundaries are in the blue lines, and once you set up the building inside the site, you can see that some areas distance are violated, and some points it is going beyond the available survey map. It is going outside, so building either has to be rotated. So there is a change in the very beginning, so this has to be checked at the very beginning. If this is so, there will be initial time extension. So this is very important that we check whether the building can be accommodated within the given boundary. A lot of projects having issues in this nature. Then take spot levels 5 by 5. Don't miss these basics. Then get benchmarks. Jointly agree the benchmark, the ground level, the road level, and the excavation levels, all in writing jointly. So one example is you have the soil surface, then you get the reduced levels, and we assume that the rock is there underneath. So when you are doing the excavation, sometimes the consultants might assume that the rock is somewhere, and our excavation is something like this. Based on that, we decide the ground floor level, and excavation and everything is strategized on that. But sometimes when actual case is there, you can dig and see whether the rock surface. Sometimes the actual scenario would be like this. So earlier there is no rock. Now in the actual scenario, when you excavate to such a depth, there will be rock exposure. So since rock is not there, it is an extra work or additional. So it could be variation because it is not intended in the basic BOQ. So if you pre-qualify rock breaking, you will be paid, and at the same time we can ask for extension of time because it's a variation, not additional because it is not mentioned in the BOQ. If it is mentioned in the BOQ, it is extra work. So additional work or variation, whatever. It's opportunity in the early stages of the project. Then we can propose new ground level by raising this thing, and when you raise this one, your what you call cut and fill thing will get affected. Normally we have to balance the cut and fill, and if the cut is more, better, because we have additional soil where you can use for landscaping or some fill. But if it is less, if the cut is more and the fill is less, we have to import external material, which is very difficult and is costly. So it's very customary that we balance cut and fill within the site, then we can manage something like this. Then the setting out and the permanent positioning, right? Control points outside the particular building is important. So this is one project that we handle. We put our control points in the goal face green. These are permanent points. Even now it is existing. The building now completed. This is one side. We have 4 points. In the behind, this is waterfront. In the permanent structures, we have these points. So based on that, using as control points, we will be checking the tower position and also levels. So particular tower is having some plate. So you can see the plate. It is triangular shape and some curvatures also there. And we have circular columns here and there. And you will see that round, these are the circular columns, and these black dots are crossing points of structural grid. So this structural grid is avoiding the column, grid by an offset, maybe 1 or 2 meter away and forth. Then by controlling this positioning, we can continue with the surveying. So the normal procedure is we will be considering each 5th floor, 5th, 10th, 15th, and likewise as a major control plate. And once a control plate is being set in out, we have to use the control point outside. Once it is established, using that plate as correct, we will be putting another 4, 5, stories above it. So you don't check. So once you reach the next, 5th floor, we will be establishing by looking at the bottom. But once it is established, we will recheck from the outside, control points whether the positions are correct. Normally, it is plus or minus 5, 7, 10 millimeter. And when you're going up, the tower will move here and there. So that this is very important. So for that, we will be using different equipments. The perspective sheets to get the center. Then you have the optical plummet. Normally in high-rise building, we will be using at least the laser, plummet ray and the theodolite total station. So the level we have to, go by adding, by benchmarking at each floor level. Then when you're using total station, we'll be using satellite facilities. And the X1, Y1 and Z1 will be decided on that. Then construction phase, substructure and superstructure. When you take a high-rise building, you have anatomy. We have lift core, then the ground below construction, which is incorporated the piles, the raft and the basements, we call substructure. Then what is coming on upper from the ground is superstructure. So they are in the bottom, floors, maybe beyond the ground floor, 1, 2, 3 floors, we will be putting the podium. There we will be using mega columns, something like this, and large beams and span slabs, because we want a lot of space there. The large span means 8 meter, 10 meter, or even more. Then when you go in the tower, the span, get reduced, shorter span. Then we can have walls, columns, flat slabs, and repetitive. That is to, speed up. So there will be 2 different, structural system. Then to tackle that one, we will be introducing transfer flow. So when you are considering the project management, we have to control these aspects. So I have given some photographs about these bracings, then lateral bracings. Then we have outrigger beams, floor to floor, maybe each 2, 3 floors or 5 stories. There will be a large beam going out and connecting ring beams or truss beams, which is going around. That is to stiffen the building. Then there will be a basement, a larger basement, then basement raft, which is happening underground. So this is how it goes when you get the land to do the fencing. So this is existing rock, maybe 20, 25 meters down. Then excavation, proposed excavation depth is 9 meter, we assume here. So what we will do is we put the hoarding. Then we will be putting the external shoring, do some initial excavation. Then we'll do the piling up to the rock. Then excavate in the tower area, the middle part, which is in the anatomy, the tower section, this one, that footprint. So that footprint, we will be excavate that one first, not whole. Then hack the piles, then do the basement, ground first, like, construction. So the tower is moving, keeping the balance work, that is the podium, to later stage. Then later on do the excavation and complete the basement. While you are doing so, the tower moves. Your tower section is the most important, that we have to start at our earliest. And when you are doing so, we have to get the borehole soil investigation log. This is one example. 3 borehole logs are there. And different soil layers are there. So these are the samples. Then boreholes size. Then what is most important is the layer, and establish where the weathered rock first comes in, where the weathered rock ends. Then when you get the hard rock starts. There, the better rock is comprising 2 layers. The topmost generally is fractured, but it is supposed to be solid rock, or rather hard rock. And bottom is solid rock without cracks. So sometimes the cracks goes up to some depth, but you can during the soil investigation you can have some idea where the weathered rock, what is its thickness, then where the fractured rock happens. So normally the pile, there is a rock socketing, that is rock anchor, at measures from the bottom of the weathered rock to the hard rock. Normally this rock socketing counts from that bottom of the weathered rock and it goes up to solid rock. Normally it is for a high-rise building of 20 stories, we have to have at least 1 meter rock socketing. In some areas I have done about 6-7 rock socketing into the rock. And we have to do the piling. So when you are doing the pile, there are different things that you have to concern. I will try to show you. Bentonite is very important to stabilize the ground. And identifying the weathered rock, fractured rock, and the solid rock is very important. And we have to maintain a pile log, something like this. So it's very important project management tool for monitoring piles. There we will be incorporating the pile number and the pile diameter. Then we will also include the machine number, operator's name, then the toe level, the cutoff level, then the weathered rock top level, bottom level, then total pile length, and the weathered rock socket thickness, then hard rock socket thickness. But normally rock socketing is hard rock. Weathered rock also we measure. If there's a deviation from the given soil investigation report, the rock socketing, the weathered, we can make a claim. So here you can see that 2 meter, 1 meter. So we can claim for that. Because normally we say in the pre-qualification, if by looking at the soil report, So we assume that the weather drop thickness is 2 meters, and we will charge weather drop boring also as soil. But if it is more, we can ask for a better rate. Normally, the boring rate is for 1 meter is 150,000 or maybe 200,000, 1 meter. So soil boring is about 20,000, 30,000, 10,000 even, very less. It is going beyond, like 4 meters, 5 meters, 7 meters in addition. So we can have a claim. So how you are going to make a claim is by looking at a tool like this. Then rock socketing. Rock socketing, here you can see that 1.5 gone, 1. So if the rock socketing 1 meter, if somebody asks to do more, it's a claim. It's a claim. So please monitor these things. If it is going beyond, even from the client side, we can question why you are going more. So there should be some reasoning. Other against 1 meter, rock socketing, you have done 1.6 meters, 0.6 more. What is the cost per pile? Is about 75,000. So 75,000 into number of piles more. So there will be a claim. So to control, we have to have these monitoring techniques. Then boring, rate, penetration rates of rock and hard rock, very important. And other aspect is the concrete pouring time, then the concrete usage. Normally 20% is given, more than 20% means less, losing for the contractor. So here, one example is in the third line, you can see that the concrete wastage is 200% or 215% or 14%. So it is, we have done double the concrete. Why? There could be a claim option, or maybe we can penalize the contractor for not doing good bentonite, stabilization, doing very bad, boring methodology, something like that. So likewise, we can get, we have two pile types. One is going to the bedrock. Sometimes it's friction piles, not going to the bedrock. Normally in high-rise building, we go for bedrock. And negative skin friction is there. That is addition to the loading that is happening when there's a fill, a recent fill without compaction. So during the construction, there will be the soil gets settled because of the compaction, and also with time, the consolidation. And because of that, soil settles downward, and it will give a downward drag, which is called downward, skin friction. Normally, the skin friction is against the pile movement. So, this means that the pile loading get increased. This effect could be 10 to, sometimes 40%, very significant. So we have to see whether the negative skin friction is happening. Happening only, there's a loose fill or consolidated oriented soil. So that's very important in the design. Otherwise, the piles might, get settled, building settles. So unforeseen ground condition also will be there in when you're doing piles. Sometimes there will be a hole. So if you do concreting, they will endless concreting. Because of that, sometimes you have to put a cylinder from top to bottom, and it cannot be taken out. It is permanent. You claim. Then how we identify by soil log. Then we can also use this scanning technology called soil resistivity imaging. Then we have to do the piling, and later we have to see the offsets. Offset has to be plus or minus 75. Beyond that, we have to alter pile caps, and it is a responsibility of the piling contractor. Sometimes the piling contractor do and vanish. Main contractor has to take this bad piling effect. Because of that, normally we keep a big retention from until this is cleared from the piling contract. So these are very important that we violate or give extra conditions in the contract, because for example, we can say that if you take 70 pile, offset is 165, 268, allowable is 75. So it is beyond something. If the pile is more than 300 millimeters, sometimes because of the eccentricity, we might ask the contractor to do an additional pile under their cost. But small deviation, even 75, it's acceptable. Beyond that, sometimes we might ask the contractor to do a fresh design, increasing the pile cap reinforcement, and also sometimes thickness. Managing the project, sometimes it is profit making, sometimes it is losing. So these are some of the gadgets in piling, and there are challenges of the piling, edge collapsing and the positioning. What we will do is we'll put a cylinder, then that challenge get rid of. Then later on, when you are going beyond the water table, there will be water pressure, water pressure, and the edges collapse into the thing. To stop that, we will be putting the bentonite. So internal pressure is more. Bentonite is coming up to the top, and the water is something. So there will be two different hydro, pressures, but the internal pressure is so high. It is bentonite, density also higher than water. What will do is it will push us the water in the pores, groundwater, and bentonite enter into the soil skeleton, which will definitely stick the soil recesses. There will be gumming effect. Then that effect we call edge stabilization. So because of that, edges might never collapse. So that is second challenge. Third challenge is identifying the weathered rock top, hard rock top, hard rock bottom in the rock socket. It's very important. By how we can have the visual inspection, then sound of augering, then penetration rate, and also from the report of soil. Then other challenge is end has to be cleaned. So when you're putting augering and bentonite, sometimes there will be a lot of pebbles and everything collected at the bottom. Bottom is not clean, because bottom is the most important in the piling, which will give the. We will do is we will do end flushing, clean in the end. So then we will. So this is identifying the visual sample of weathered rock. Fractured rocks. Fractured rock have some crust on the face. Then solid rock is solid. Then this is the concreting. When you're concreting also, once it is bottom is clean, you pour the concrete to the bottom using trimmy pipe and the funnel. And the first concrete will mix with bentonite because of the drop, and the concrete become weaker, density become looser, 1,500 kilogram per meter cube light. But the original concrete is 2,400 kilogram per meter cube. Because of that, two different material, density higher is original concrete. So once you pour continuously, better concrete goes bottom, and there will be a frontier of bad concrete floating over the better concrete. So always the tip has to be kept under better concrete, right? So that is how you would do a better the concreting. This is some operations, the cylinder bracing, the under ream, if possible, if wanted, if in the design. So it's a larger portion in the middle, which will increase the bearing capacity of a pile drastically. Then in the pile also we have testing, right? So the static load or maintain load test, which is a prototype test, where we measure the settlement and so on, and also testing, PDA. Then under PDA we'll be getting the beta value. Then PIT test, that is a pile integrity test, small test. There it will give the integrity, the beta value. Then also we have Osterberg cell, O cell, where we will be putting a jack inside and load it using pressure, loading. So there we will be giving pressure to the jack. Jack will accept both the pressure, bottom and top. Then we will be measuring the bottom settlement and the top settlement. So we can check the bottom concrete using this test, but it is very costly test. These are some of the test, costs. Static load test is nowadays 2 to 3 million. Dynamic is 1 million. Integrity is 20 to 15 million. Sorry, 15,000. This is 1 and 3 million. These are the proportions. Sometimes 1% static load test, 1 to 10% is dynamic. Then likewise, OCell. OCell is 20 million, one test, not practical.
Galin. 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 నేను కూడా మరి అవి టాయిలెట్ కి కప్పుడు కాంటి ఏంటి అవి టాయిలెట్ కి అక్కితే కాంటి ఏంటి
I think maybe a power cut. Please let me confirm with Mr. Samit.
to mute it no I can keep power cut there it will be power cut so don't yeah you can see look don't cash they can see take you
Actually, sorry participants. Mr. Samita informed me that there's a power cut in his area, so it's difficult to continue our lecture. But he told me that he's expecting to cover the balance part in the next day, and so we will be arranging as IESL Kegalle chapter. We will be arranging another session to finish the session as planned. So thank you all of you guys, and I hereby invite our IESL Kegalle President, Mr. Prabhat, to give the vote of thanks. Mr. Prabhat.
Thank you. Yeah, good evening to everybody. Actually, it was a very interesting and also informative session for all of us. I'm sure that you all have got a lot of learning and also got a lot of knowledge from this CPD session. What we call strategies for project management and good practices for construction management. I sincerely thanks our resource person, versatile engineer Samita Jayapuri, for conducting us this valuable CPD session for IESL District Center, and also sharing his knowledge and also experience with us today. Once again, actually, I want to thank him for allocating his valuable time and with the busy schedule for us, and also everything in free of charge. It means a lot for us. And also I would like to thank all the participants who joined today around, I think more than actually they assist us to
I think another. Okay.
And also finally, I would like to thank Dr. Kamal Laksiri and IESL head office staff for arranging this Zoom platform for us, and all the other arrangement circulating this message to all the engineers around the country. And hope that we will meet again with our future event and also second part of the second phase of this seminar. And also I want to say that good night to all of you. Thank you very much.
Thank you, Engineer Prabha, and hopefully we will arrange the next session as soon as possible. So again, I would like to thank you all the participants who make this session a fruitful event. So I think the time to wind up the session. Hopefully, again we will let you know the exact date and time for the continuation of this session. So hope you enjoy the session, and thank you very much, and good night.